Timeless concepts from Physics Helpline. In this video tutorial, we will discuss 3 multiple choice questions taken from the NEET exam of 2019. The questions are as follows. Question 1. A body of mass m is kept on a rough horizontal surface. The coefficient of friction is given as mu. A horizontal force is applied on the body, but it does not move. The resultant of normal reaction and force of friction acting on the body is given by F. We are required to find the value of F. The options are given in the question. We are required to find the correct option. Now for the answer. Let the applied force is equal to Fa. It is shown in the figure. Fa. Now the body does not move. Therefore, it is in equilibrium. Which means force of friction F will be less than equal to limiting friction. But the value of limiting friction is mu mg. Therefore, we can write magnitude of F, mod F, is less than equal to mu mg. Now consider the vertical equilibrium because there is no motion in the vertical direction. Our upward force is normal reaction N and the downward force is weight of the body mg. Therefore, N should be equal to mg. Now it is given that resultant of N and F is equal to F. Therefore, we can write F vectorially. We can write vector F is equal to normal reaction N plus the force of friction F. Now, let us consider equation 3. We observe that N and F. N is acting in the vertically upward direction and F is a horizontal force. Therefore, they are mutually perpendicular. Therefore, the magnitudes are related as this. Mod F square will be equal to mod N square plus mod F square, since they are mutually perpendicular. Again, we will use the equations 2 and 1. Equation 2 gives N is equal to mg, therefore mod N square will be equal to mg whole square. And magnitude of the force of friction F is less than equal to mu mg. Therefore, the limiting friction is mu mg. Therefore, F will be less than equal to mu mg. Therefore, we can write mod F square is less than equal to mg square plus mu mg whole square. Now we'll take mg square common. This has got both the terms have got mg whole square. So mg whole square into 1 plus mu square. Mod F square is less than equal to mg whole square into 1 plus mu square. Therefore, taking square root, we get F is equal to, mod F is equal to, is less than equal to mg into root over 1 plus mu square, which is the answer to question 1. Therefore, the correct option is D. Now for question 2. It is about 2 bullets fired horizontally towards each other simultaneously from the rooftops of 2 buildings, 100 meters apart. The distance between the 2 buildings is equal to 100 meters and height of each building is equal to 200 meters. The bullets are fired with the same velocity of 25 meters per second. We are required to find when and where will the two bullets collide? Acceleration due to gravity is given as g is equal to 10 meters per second square. The options are given in the question. We are required to find the correct option. Now for the answer. The situation is shown in the figure. Bullet A is fired towards right with velocity v, and bullet B is fired towards left with the same velocity v, but in the opposite direction. Now the distance between the two towers is given as 100 meters, which is shown here. The height of each building is equal to 200 meters. Let the two bullets collide after t seconds. So let us consider the horizontal motion, which is uniform for both the bullets, because horizontally there is no acceleration, only initial velocity v. For A it is towards right and B it is towards left. Let us consider the relative distance between the two bullets initially will be equal to 100 meters, because that is the distance between the two buildings. Therefore we can write xr is equal to 100 meters. Relative velocity. If this one, velocity of A is equal to plus v, then velocity of B will be equal to minus v. Therefore relative velocity Vr will be equal to v minus of minus v, which is equal to 2v. V is given as 25 meters per second. Therefore Vr is equal to 2v, which will be equal to 50 meters per second. Now since the horizontal motion is uniform, therefore we can write velocity into time will give us the distance. Velocity in this case is Vr, which is equal to 50 meters per second. T we want to find out, and xr, the distance covered, will be equal to xr, which is equal to 100 meters. Putting the values, we get 50 into t is equal to 100, which gives us t is equal to 2 seconds. Now for the vertical motion. For each bullet, vertically downward velocity, initial velocity will be 0, because it is like dropping from a height. So therefore we write u is equal to 0 for both. And acceleration g is equal to 10 meters per second square. It is given in the question. We'll be using the kinematic equation u is equal to ut plus half gt square. Now initial velocity in the downward direction is equal to 0 for both the bullets. Therefore y is equal to half into 10, that is g, into t square is 4, because t is equal to 2. Simplifying, we get y is equal to 20 meters. Therefore height of the bullet when they collide, h is equal to, because the total height is 200 meters and it has fallen through a distance of 20 meters, therefore h will be equal to 200 minus y, which is equal to 180 meters. Therefore the collision will take place at t is equal to 2 seconds and at a height h is equal to 180 meters, which is the answer to question 2. Therefore the correct option is B. Now for question 3, it is about the time period of satellites. It is given that for a geostationary satellite, the time period is 24 hours and it revolves at a height of 6 RE from the surface of the earth, where RE is the radius of the earth. Time period of another satellite we are required to find. The time period of another satellite which is revolving at a height of 2.5 RE from the surface of the earth. The options are given in the question. We are required to find the correct option. Now for the answer. If the time period of a satellite is equal to t and it is revolving in an orbit of radius r, then they are related, t and r are related as t square is directly proportional to r cubed. Now radius of Earth is equal to re. Therefore, for a satellite at a height h above the surface of the Earth, the radius r will be equal to re plus h. So, using equation 1 and 2, we get t square where it says r cubed, which is equal to re plus h whole cubed. Now, we know that for a geostationary satellite, h is equal to 6 re, therefore we represent it as h1 is equal to 6 re. And its time period t1 is equal to 24 hours. For the other satellite, h2 is given as 2.5 re. Let the time period of the second satellite is equal to t2. We are required to find the value of t2. Using equation 3, we get t2 square divided by t1 square is equal to re plus 2.5 re whole cubed divided by re plus 6 re whole cubed. Now, LHS T2 square divided by T1 square can be written as T2 divided by T1 whole square, which is equal to RE plus 2.5 RE gives us 3.5 RE divided by RE plus 6 RE is 7 RE whole cube. Now, RE and RE gets cancelled. 3.5 divided by 7 will give us 1 by 2. So, we get T2 by T1 whole square is equal to 1 by 2 whole cubed, which is equal to 1 by 8. Therefore, taking square root, we get T2 by T1 is equal to root over 1 by 8, which is equal to 1 by 2 root 2. Now, T2 is given as 24 hours. Sorry, T1 is given as 24 hours. Therefore, T2 is equal to T1 divided by 2 root 2, which is equal to 24 divided by 2 root 2, which is equal to 6 root 2 hours. Therefore, we get T2 is equal to 6 root 2 hours, which is the answer to question 3. Therefore, the correct option is B. This completes the answer to all the questions in the video tutorial. Thanks for watching. If the video is helpful, then please like, share and subscribe.